Hello, I'm Manticajon and this is my video response for gas loss number 2. So for gas loss number 2, we were given 5 problems and we were tasked to choose one problem among those 5, and I chose problem number 2 for my video response. So solve for a 5.5 liter chamber reactor that was monitored having an overall pressure of 4.8 atm. The reactor contains 4.50 mole of oxygen, 5.50 mole of chlorine, and 7.93 mole of fluorine. So determine the partial pressure of fluorine, assuming all gases are inert. So from the sentence, determine the partial pressure of fluorine, the appropriate law that we can use for this problem is Dalton's law of partial pressure. So identification and solving. So again, as I've said earlier, the appropriate law that we can use for this problem is Dalton's law of partial pressure. So there are steps in getting our answer. So for this step 1 is we need to identify what is being asked. So in step 1, I am tasked to look for the partial pressure of the fluorine gas. So step 2 is we need to identify what is given. So the given is the total pressure of 4.8 atm, and the reactor contains 4.50 moles of oxygen, 5.50 moles of chlorine, and 7.93 moles of fluorine. We also have the volume, which is 5.5 liters, but we only need to look for the partial pressure, so we don't need to involve the volume. We can disregard that. So for step 3, we need to write the working equation. So solve for the fraction, then determine the pressure of fluorine. So the total number of moles equals to n sub A plus n sub B plus n sub C, and the mole fraction equals to n sub A over the total number of moles equals the pressure over the total pressure. So for step 4, we need to substitute the given values of the equation that I've said earlier. So the total number of moles equals to n sub A plus n sub B plus n sub C, substituted to 4.50 moles of oxygen plus 5.50 moles of chlorine plus 7.93 moles of fluorine. So as we add 4.50, 5.50, and 7.93, we will get 17.93 mole. So for the mole fraction, we need to substitute the moles of fluorine and the total number of moles, which is n number of moles of fluorine over the total number of moles. So therefore it will equal to 7.93 mole of fluorine over 17.93 moles, or 7.93 moles of fluorine divided by 17.93 mole. So if we divide 7.93 over 17.93, we will get 0.442 moles of fluorine. So for the last step 4, thus the partial pressure is equal to the mole fraction times the total pressure. So we will multiply our mole fraction, which is 0.442, times the total pressure, which is the 4.8 atm. So 0.442 times 4.8 is equals to 2.1216, which is equal to the final answer, which is 2.12 atm fluorine. So the partial pressure of fluorine is 2.12 atm. So that is the answer for problem number 2. So I hope that I've explained my problem well, and thank you for listening.